And one example, which I think when we're talking about edge detection, this is a very interesting case of a convolution, you can say. So here the kernel is kind of, you can say it's an edge, because we are going from positive values to like 0 and then towards negative. All right, so this is kind of an edge you are seeing here. And this pattern is actually something which we are trying to find in the input image. And this is something for the edges in the y direction. So even when we're trying to perform Sobel edge filtering using these filters, we were trying to find these patterns in the input image. And if we were able to find this pattern, we get a high response, and that's how we detected those edges. Okay, so in this case, if you think about the convolutional neural network, the structure I showed you, the input image is the, let's say, some kind of volume you have like in your network. In this case, it's like input volume. And these are the kernels. In this case, these are handcrafted. But for CNN, we are going to learn these kernels. Okay, so these are the kernels. And these are the output activation maps, which we are going to stack together to again form a feature volume. So in this case, if we have like 2 different kernels, we got 2 different activation maps. We can have several other kernels. We'll get like similar, like the activation maps corresponding to those kernels. And then we can stack together all these activation maps together to be again like fed to another convolution layer in your architecture. So let's try to understand this operation. I will show you like several visuals so that everything is clear and there is no doubt once we are done with this lecture. So let's say this is your input image patch. And in this case, it's a binary image. So 1 represents like a very, you can say like foreground, and 0 represents background. So in this case, you can see like this is some kind of, in this area, it's highly active. And this is kind of background, right? So in this case, if we try to use a filter like this, if you try to visualize what this filter represents, it's simply a cross, right? So then ideally what should happen is if you use this filter over this input patch, it will give you activation map, which will represent which location you are able to find these crosses in the input image patch. Okay, so if you carefully analyze this, I mean, we don't have any crosses at all, right? We do have partial crosses. For example, you can look here. So this side we have, but if you look at the other axis, I mean, this is kind of half cross, right? If this would have been 1, this would have been a perfect match. Then let's see like what will happen if we try to convolve this filter on this input image patch. So you can apply like at this location, again, it's element-wise multiplication. You know how to perform filtering. You just perform element-wise multiplication and add those values. It's going to give you 4, 3, again a 4. You can keep doing that, okay? So now if you try to analyze like what kind of activation map you got, the highest value was 4, right? And you got that value at 3 different locations. So if you try to analyze what the input image patch was at these locations, then it was kind of partially matching with the cross. Not a perfect match, but still it was like some kind of match, okay, even at this location. And the lowest value is 1, which is at this location. And you can see that it's the only match we have is for this location, right? If we try to create a crosshair. And that's why it was like very, it was not highly active.